Good evening, friends. Today, let us solve another beautiful problem. Here, there is an equilateral triangle, right? There's an equilateral triangle, the big one, the red one. And within that equilateral triangle, the midpoints are joined to create another equilateral triangle, the green one. And within that green one, again, the midpoints are joined to create another equilateral triangle, which is the blue one, right? This process continues, and infinite number of triangles are being created. Right. This is the first triangle, this is the second one, this is the third one. Within the third one, there's fourth one, fifth one, sixth one, whatever. There are infinite number of triangles. And the first triangle, the side of first triangle is A. Now, what is the sum of perimeters of all of these triangles? Is it infinite? Is it some finite number? What exactly is that? Right. This is a beautiful problem. We know the perimeter of first triangle is 3A. Right. Now we have to find out the perimeter of the ones which are inside this. Okay, let us do this. It is given that midpoints are being joined, right? D, E, F. These are midpoints of AB, BC, and AC, right? Now, these are midpoints, right? Because this is an equilateral triangle, AB is equal to AC, right? All sides are equal. AB is equal to AC. And because D is the midpoint and F is the midpoint, that means AD, which is half of AB, is equal to AF, which is half of AC, because AB is equal to AC. So basically, AD is equal to AF, right? Now, this angle is 60 degrees because this is an equilateral triangle, and these two sides are equal. What does that mean? This angle and this angle should become 60 degrees. What does that mean? All three angles are 60 degrees. That means this red one is again an equilateral triangle. Similarly, we can prove this red one is also equilateral triangle. This red one is also equilateral triangle. And what is the side? Side is half of the original side, which is half A by 2. Right. This triangle, each side is A by 2. This triangle, each side is A by 2. And this triangle, each side is A by 2. What does that mean? This green one is sharing the sides, right? What does that mean? The green ones, each side is also A by 2. Right. When the original triangle is of the sides A and midpoints are joining, then the triangle which is created inside is also an equilateral triangle, which is of the whose side is of length A by 2. Right. So that's what we have written here. DF are midpoint. So AD is equal to AB by 2, whatever. And finally, ADF, this is equilateral triangle, and DEF also equilateral triangle. And which side? A by 2. Right. If DEF is A by 2, what is this blue one? Blue one, the side would be A by 4. And the one within the blue one, the side would be A by 8. And the one within that, A by 16. Like that. Right. The length of the side will halve every time. Right. Now, what is the perimeter of the first triangle? Side is A, so it should be 3A. What is the perimeter of the second triangle? It should be 3A by 2, 3 into A by 2. What is the perimeter of third triangle? 3 into A by 4. So the perimeter is going half every time. So what is the sum of perimeters that we need? This is this expression 3A plus 3A by 2 plus 3A by 4 plus 3A by 8 plus 3A by 16 plus so on to up to infinity. Now, if you see, this is actually geometric progression, right? Geometric progression, we already know the sum of series which is in geometric progression if are running to infinity if the ratio is between -1 and 1. This we have proved also earlier. The sum of series in geometric progression, if r is greater than 1, then a into 1 minus r power n by 1 minus r. If r is a proper fraction, then a by 1 minus r. This is the sum of infinite series. What is a here? A is 3a. And what is r here? The second term by first term is half. Third term by second term is also half. Every term is being multiplied by half is being to get the next term. So a is equal to 3a and ratio is half. So 3a by 1 minus half, 6a. So the sum of perimeters is actually 6a only. Right. This is a beautiful problem. And we have already derived this a by 1 minus r. There is another video which gives us the proof of this. a by 1 minus r. This is that video. In this video, we have proved the sum of geometric series of n numbers, and when r is a proper fraction, how to derive this a by 1 minus r from this generalized sum of geometric series. Right? Please go through this to get that understanding. Hope you like this problem. Thank you, guys.